All right, let's move on to example 3. You'll notice it's similar in that we can't find a common base. The difference, of course, is we have x in 2 exponents. But our strategy is going to be similar in that we're going to take the log of both sides. So first I'll give you a second to write down example 3. So it's 2 to the x plus 1 equals 3 to the x minus 1. So we'll take the log of both sides. And again, our strategy still holds true in that this gains us access to the exponents. So the x plus 1 exponent can come out front, as can the x minus 1 exponent on this one for log 3. The only catch is isolating for x now will be a bit of a challenge. So don't write this down, but just watch. Like if I tried to get rid of this by dividing, then I'd have x plus 1 equals x minus 1 log 3 over log 2. And then if I wanted to get rid of this one, I bring it over here. So this would be divided by x minus 1. And this is what we have. So sure, the x is on both sides, but now it looks like a rational. And if you remember from last unit, the rationals we dealt with by multiplying. So we would bring this back and we would end up at the same spot. So we need a different strategy here. We can't isolate for x because x is in 2 spots. So the way we do this is we're going to rainbow this log 2 in. Remember, log 2 is just a number, so it can be rainbowed in here and here and here and here. Okay? So we'll rainbow it in. So x times log 2, I'm just going to go x log 2. And then log 2 times 1 is just plus log 2. Rainbow the log 3 in, we'll have x log 3. Because we're just multiplying, and then multiply by negative 1, of course, this is going to be negative log 3. So since log 2 is just a number, we're rainbowing it in. Normally that number we'd put in front of the x, but remember, we like to have the number after the x in this case, so there's no confusion as to what you're taking the log of. Okay, so what the rainbow step does is now it makes it a little bit easier to isolate for x's. So let's get all the things with x's on one side and our numbers on the other side. So this x log 3 is going to stay here, or log 2, excuse me, but this one's going to move. This one's going to move. So it's just x log 3, so when it comes over here, it's going to be minus x log 3. Over on this side, we'll have negative log 3 is already here. And this log 2 is going to move and become a minus log 2. Now at least I have the x's on the same term. I'd like to collect like terms. So I've got an x here and an x here. So together I would add or subtract the coefficients. Remember, if this was like a 3x, or let's not use 3x. If it was like a 5x minus a 7x, we would go 5 minus 2 and get negative 2x. Well, it's not a 5 and a negative 7, but a log 2 and a log 3. So we can add or subtract the coefficients. The way that looks is this. So we'll keep here, and we'll subtract the coefficients in this case. What it looks like you did is you took out a common factor of x, which is one way to think of it. The other way is to think that you're just adding or subtracting the coefficients. On the left hand or the right hand side, nothing else changes. The good news is what you have now is x times this whole thing. So if I want to get x by itself, I'm going to divide by this whole thing. And I got to do it to both sides. And then what happens is I'll have x by itself, and we'll get negative log, oops, got the wrong color there. x is equal to negative log 3 minus log 2 all over log 2 minus log 3. Again, that's the exact answer. You can carefully put this on your calculator, and you'll have to make sure you're careful when you do it. Make sure you have, a number on the top and then divided by a number on the bottom. You might need to use your memory button. But there it is to 4 decimal places. This one, most likely, I'll probably just ask you for the exact answer, so you would stop there. But if I wanted the decimal, you would go a step further. Okay, so overall, the same idea in that we have to take the log of both sides. So we took the log of both sides. That gains us access to the x. But in this case, we had a rainbow in, collect like terms, and rainbow out, or factor out. So we get to this. And one final example is example 4. So here we have 9 times 3x equals, or 3 to the x equals 2 to the x plus 1. So the only reason I'm bringing this up is because it looks different than some of the others. We can't lose sight of the fact that when we have common bases, we should take advantage of it. So let's not forget about that. So here we have a 9 and a 3x. Those can be expressed as common bases. So at least there I can change this to 3 squared and this to 3x. This I can't, so I'm just going to leave as 3x plus 1. And now what you see is you have two numbers being multiplied together with the same base. Our exponent rules tell me that when they're multiplying powers with the same base, you can keep the base and add the exponents. So all I've done is just done a little bit of work at the beginning to make this question a little bit more manageable. Take advantage of common base when they're there, and when they're not, then you got to go the step further. So here we would take the log of both sides, and the rest will be the same. And I'll let you finish that off. If you want, you can do it on your own to get it. It'll be exactly like example 3, so another chance for you to practice it. Here's what the answer is going to look like in the end.
Tyler Dunn. Contact the office, please. Tyler Dunn.
Okay, so the only reason I showed you this last example is to remind you that when you have common base, take advantage of it. When you don't, you still have to take the log of both sides. I'll let you practice that on your own. That's what the answer should be, and if you want to compare that with a neighbor, you can. Okay, so that's it for now. Time to practice. Practice can be found on page 485, number 2, 10, and 17. You should have lots of time to practice today. Of course, if you get that finished, you can look at finishing some of your practice from the last couple of days. Good luck.